Hello everyone and welcome to the first part of lecture 3 and section 2. So the part 1 have two sections. We have the formula P equal rho GH, and this is the pressure equal the density time gravity acceleration and the height of the column. Okay, sometimes this is the pressure, sometimes the height of the column we name it as a pressure. We will know how can we separate it with them. How can we know we talk about the P or how can we talk about H? First of all, you should know the rho. We have two liquids we are using. We are using water and we are using mercury. So this is constant. You should memorize them. For water, the density is equal 1,000 kilogram per meter cubic or 1 gram per centimeter cubic. For mercury, it's 13.6 gram per centimeter cubic or 13.6 times 10 to the power 3 kilogram per meter cubic. G is the 9.81 meter per centimeter square, 981 centimeter per second square. So, and H is not constant, so it will be changed. So it should be centimeter, sorry here, it's just like centimeter, millimeter, centimeter, millimeter, and meter. Okay, so start with the water. The water have 1,000 kilogram per meter cubic. If we are using this unit for water, okay, the G should be using for meter per second square. All right, and the result for and H should be in meter. So all these units should be using together. If you want using, this is important. If you are using gram per centimeter cubic for water, then for G you will use this unit, and it will be this unit for H as well. Again, if you are using for mercury, if you are using this unit, then for G you will use what? This unit, and for H will be this unit. If you are using mercury for this kilogram per meter cubic, that means you will use G for this unit, and then M will be using. What about millimeter? Millimeter, you will not use it. Millimeter, maybe you will find it. For example, if you have a centimeter, you will transfer to the millimeter. Okay? Or if you have meter, you will transfer yourself to the millimeter. Then you will have some examples to understand how these work. Start with what is the height of water will produce the same pressure as 100 millimeter mercury. Okay? So 100 millimeter mercury, when you see 100 millimeter mercury, that means he's talking about H. Okay, so H is 120 millimeter mercury, and mercury is the indicator. You will use what? You will use the density for the mercury because he said mercury. Okay, so now we will rewrite again. What is the height of water? So H of water is required. Okay, it will produce the same pressure as 120 millimeter mercury. The H of mercury is given 120 millimeter mercury. Now from H of water he wants H of mercury, he wants H of water. How can we know that? First of all, we know that P equal rho GH. Okay, the pressure for mercury, I will say M, equal rho for the mercury. Rho for mercury is up to you. What do you want to use? Because he didn't mention here. You can use this one or you can use this one. So I will use what? I will use this one, a gram per centimeter cubic. So it will be 13.6. So rho is 13.6 gram per centimeter cubic multiplied by G. Because you are using for mercury this one, you will use G for this one as well. So centimeter should be centimeter here and centimeter here. So 981 okay, then multiply by H. H for mercury is 120 millimeter. Okay, I cannot use millimeter because why? Because this one I have centimeter. This one I have centimeter. This one should be what? Should be centimeter as well. Because I have it millimeter, so I will divide by 10. It will be 12 centimeter mercury. Okay. Then B for mercury will be equal Multiply them together, you will have uh, 10 to power 5. Just give me a second. You will have 1.6 times 10 to power 5. What is the unit? Dyne per centimeter square. Okay, so here again, if you are using the centimeter and centimeter here and centimeter here, the unit will be dyne per centimeter square. If you are using meter here and meter here, meter here and meter here, that will be Newton per meter square. Okay, so depend on the centimeter or meter, you will understand what type of unit that you use. Now he said, is it producing the same pressure? That means PM for mercury is the same as P for water. So I will use it the same. So P for water equal rho GH. P of water 1.6 times 10 to power 5 equal rho, which is now for water. I am using for water. So rho for the small unit, rho for small unit is 1. Okay, because I'm using the centimeter one, so it will be 981 multiplied by h, which is the required, the height of the water. Okay, then the answer will be h. If you divide this one over this one, it will be 981, 1.6 times 10 to power 5. H will be equal 163 centimeter. 163 centimeter. And this is the end of this example. Another example we have is just like during forced excitation, such as when you are pulling up a balloon, the diaphragm and chest muscles create a pressure of 60, listen to me guys here, create a pressure of 600 millimeter mercury. He said the pressure, but that pressure not P, okay? So it's not P. As I said before here, this one is a pressure, and this one, maybe sometimes you name it a pressure. So which one is this one? 60. Because the unit is millimeter mercury. Okay? So let me write note here for you to understand it. So the pressure is in Newton per meter square, and it's named pressure. H is millimeter, meter, centimeter, or millimeter, and we name it as a pressure as well for this case. So when he told you to create a pressure of 60 millimeter mercury, that means he's talking about what? He's talking about H, not talking about what is said P. Between the lungs and the chest wall, what is the force in newtons? Okay, he wants force in newtons. Okay, force, as I explained in the, you will find it, the force is equal, the pressure is force per area. That means force, it will be pressure multiplied by what? Multiplied by area. When he said this one should be in Newton, so that means the pressure will be what? Newton per meter square or Dyne per centimeter square? Of course, because this one is in Newton, you will use Newton per meter square. And because P is Newton per meter square, what I will use for rho? It will be this one or this one. Of course, I will use the meter square if it's water. Or I will use, because it's talking about the mercury, you will use this one as well. For G, you will use 9.81 millimeter per second square. Okay? And for H, should be using what? Should be using the meter. All right. Let me return back again. So now I know that the H of mercury is equal 60 millimeter mercury. Okay? H will be 60 times 10 to power minus 3. I want to transfer it to the meter because this is what I want. He wants the force in Newton. Okay? This pressure created for the 600 centimeter area. The area is given 600 centimeter square. Okay, now let's start to solve it. First of all, we know that the pressure equal F over A. That means F will be pressure times A. Be careful, guys. Pressure of 60 millimeter mercury is not P, this one. No, it will be what? This one is H. So I don't have P. So that means F will be equal rho G H multiplied by what? Multiplied by A. We know that P is rho G H and then multiplied by A. All of them should be what? I will do star for them. For P, for mercury, I am using mercury because he said mercury. For B is mercury, I will use this one. So I will put a star on it. For G, because I'm using meter here, I should be using meter here. So I will put a star on it. For H should be what? Should be meter as well. Okay. What about A? A should be meter as well. So meter square. Okay. A should be meter square as well. So it will be F equal. Start with the rho. We are using for mercury. This one he said mercury here. He said mercury here. Okay. We are using for mercury. So rho is 13.6 times 10 to power 3. Multiplied by G is 9.81. Multiplied by H, which is here is 60 millimeter. I transfer to the 60 times 10 to power 3. 60 times 10 to power minus 3 meter. Okay, and after that, the last one is A, is 600. Not just 600. A should be 600 times 10 to power minus 4 meter square. I should transfer it what? To the meter square. So it will be 600 times 10 to power minus 4. F will be it will be multiply them together, like you can multiply them all them together, and the unit will be Newton because you are using kilogram per meter cubic here, meter per second square here, meter here, and meter square here. So this is meter square. Let's say I will put the unit so you understand it. This is meter per second square, and this one kilogram per meter cubic. Okay, and this is the last the answer that we have it. The second one is just like one way to force air into an unconscious person lung is to squeeze on a balloon appropriately connected to the subject. What is the kg pressure of 4 centimeter of water? He wants the pressure. But what the pressure? Of 4 centimeter of water. So you have H. That means this one will be what? Will be B. Assume that you are squeezed on the effective area of 50 centimeters square. Okay, so now again, one way to force air into unconscious pressure lungs is to squeeze on the balloon appropriately connected to the subject. What kg pressure? What is kg pressure? Of 4 centimeter water. Okay, of 4 centimeter water, assume you're squeezing on the effective area is equal to 50 centimeters square. Now, you have the area is 50 centimeter square. You have H is equal 4 centimeter. I talk about what? We talk about the water. What he want? He want the pressure. Okay, the pressure is rho GH. Okay, the pressure is rho is just like we are talking about the water. Okay, so it will be 1 gram per centimeter cubic. Okay, I will use this one. Okay, it's up to you. You can use this one or this one because he's not mentioned what type of unit you will use, but you will use this one as well. So it will be 1 multiplied by the gravitational force is 981 or 980 is the same. For H is 4 as well. Okay, so the pressure will be is equal, you will get the answer here, 9 per centimeter square. Okay, and this is how to solve it. Now we have a third example here, and to who will listen to me, this one is homework. Okay, I want it next week solved individually. Okay, so so give it to me by 1 of October 2023, or for section 1, section 2, section 3, and section 4, section 5, you will give it by 2 of October 2023. Okay, thank you very much.